Good morning class. Welcome to this very first lecture of tool engineering. So you are in the 7th semester now and I will be teaching you the subject tool engineering. So these are my details. I have already been in this institute since last 12 years. Now to begin with, in this subject we are having 6 units as we have in all the other subjects. The very first unit is the theory of metal cutting, then single point cutting tool, then broaching, then certain machining processes, then taps, dies, and then the design of dies. So this is what the syllabus is going to be, including jigs and fixtures. So we'll be starting with the very first unit today, that is theory of metal cutting. So basically we all know what do you mean by metal cutting. Metal cutting means cutting of a specific metal. So what are the different types of manufacturing process here? Chip formation and chip place process. So chip formation means whenever you are going to cut the metal with the use of a cutting tool, chips are going to form. Chips means that the material is removed from the metal in the form of chips. So such processes are called as chip forming processes. Now they are continuous contact, intermittent cutting. So here are the examples. You can see single edge, then turning, shaping, boring, double edge, it is drilling. So I'll show you in the detail what is drilling. So drilling is an operation wherein a drill is being inserted in a particular tool, it is being moved. Single edge means the cutting tool is having only one edge. Shaping means the shaper has only one cutting edge, and same is about boring. Intermittent cutting means milling. So we already know, we have seen milling. Mill means a specific gear or a cutting tool is located and it is having certain number of teeth. So one teeth comes in contact one time, then another teeth comes in contact after some time. The same teeth comes in contact after some time. So that is milling. I'll show you it in the details. Now chip place process, it is rolling, spinning, forging, drop stamping. So we know forging means, that means we are pasting a particular forging. We have already done forging, we are going. That means we already know what we mean by forging. What is stamping means? Stamping means we are going to produce coins with that. So there is no cutting of the material. There are no chips formed, but the material is being removed. Same is about forging. We already know, we have seen hot forging, cold forging, so many types of forging in manufacturing processes. So again in that there is no need to cut the specific metal. So these are non-chip forming processes. So basically it is classified into chip forming and non-chip forming. Now what are the different kinds of machining operations? The most important machining operations are, you can see here, that is turning, drilling, milling, and other are shaping, broaching, planing and sewing. So turning, the very first and the basic operation. What do you mean by turning? So here you can see the workpiece material. So I'll explain you here. This is the workpiece now, and this is the cutting tool. So this cutting tool is placed against the workpiece and this workpiece is rotating. So you can see the workpiece is held in a particular chuck in a lathe machine. We have seen that, and it is rotating. The workpiece is being provided the motion. So here you can see the workpiece is rotating and the tool is fed past. So this is the direction of the tool. In this direction the tool is being fed. You can see here the tool is fed in this direction. The workpiece is rotating like this and the tool is fed in this directions. So it is rotating like this and the tool is passing against that workpiece with a particular depth of cut provided, and thus the material is being removed. So you can see this was the initial diameter of that particular workpiece, and now you can see the diameter is reduced to this one. So this was the original D and this was the diameter which is remained after the material is being removed. So that diameter is small d. So you can see here how this particular operation works. The workpiece is being rotated with a particular speed, and against that rotating workpiece the cutting tool is moved. The cutting tool is moved against that particular rotating workpiece, and thus the material is being removed. And here you can see the chips are being removed like this. So this is the first operation, that is turning. Now the next one is drilling. So we know what do you mean by a drill. A drill means it is a cutting tool which is having certain number of cutting edges, basically 2 cutting edges, and what happens, drilling is used to drill the holes. The basic purpose of drill is to make the holes in a specific workpiece. So here you can see this is the workpiece and this is your drill tool. Now again the drill tool must be held in a particular arrangement and the workpiece is kept like this and the drilling machine is forced into it. Drilling, we have already seen it. We have also seen the working of drilling at our homes also. While we are trying to make the holes in a wall to put some screw there. So there they use the drilling machine, that is, which is a portable drilling machine which can be used directly by a hand. Now this we are talking about here. It is shown that a particular drilling machine in which a drill bit, it is fixed into a particular tool holder, and then it is being moved. Here you can see the workpiece is stationary. यहाँ पे workpiece की movement नहीं है, the workpiece is stationary and it is rotating and again moving in this direction. So it is having two motions. It is rotating a rotary motion and again it is going into this reciprocatory motion, and this is how it goes on and makes the required hole that we required. So that is the next operation, that is called as drilling. It is used to create a round hole usually by means of a rotating tool drill bit that has two cutting edges. So generally a drill has a two cutting edges. Now we will see in details about these operations, about this in the next lecture when we are going to study about the drill, but being just an introductory part, we have to just understand these things. Now the next is milling. So here we see this is a milling tool. So now this is also a milling tool, this is also a milling tool. Now here you can see the milling tool, it is a milling cutter. Now it has certain teeth on its edges. It has certain teeth on its edges here, or it has certain teeth over its periphery. That means it is having teeth over its diameter on that particular thing, and with this teeth the workpiece, the tool is advanced in this direction. Now here the workpiece could be stationary and the cutting tool, that is the milling cutter, might be in the rotating motion or will be in the motion, or you can also move the workpiece and the cutter would be in a stationary motion. So there can be so many number of options in milling, but what we have to understand, what is milling? Basically it is a cutter, it is having number of teeth, and this teeth comes in contact with the workpiece material and that the workpiece is removed. But being having number of teeth, so when first teeth comes in contact, then it is again rotating, then the second teeth comes in contact, so it is called as intermittent. It is not continuously cutting, it is one by one teeth, second teeth, third teeth, they are coming in contact with the tool material, and thus the material is being removed from the particular tool. So that is milling operation. Now this is peripheral milling and this is face milling. Face milling means you are milling this particular face part. So this is face milling. Here you can see this is a milling cutter. Now this is a feed motion of work. The work here you can see the work is fed past against this cutter. Here also the work is fed past against this cutter, and this cutter is having the rotary motion. So we can see the cutter, it is rotating and the workpiece is being fed past against that particular cutter. So this is the milling operation. So these are the three basic operations, that is turning, drilling and milling. Another operations are, as we all know, as we have seen, that is shaping and planing. So we already know shaping and planing are different machines. We have already seen that. We will see it again details in the coming lectures. So shaping and planing means it is a shaper is a machine which is having a cutting tool fixed to it, and in a forward stroke it completes the cutting operation and returns back. So that is also cutting operation. Then broaching. So we have a detailed chapter broach, we will study there. A broach is a continuous tool with having so many number of edges on that. So and with one stroke of broach or two stroke of broach we are going to get the entire operations done. Sawing we already know. Sawing means we might already seen sawing, that is it is having a cutter, it is having number of teeth, and with that you are going to cut. You must all have seen this cutting of woods by the particular saw. So we just wanted to understand here what are the basic manufacturing operations. Just to know, these are the different kinds of manufacturing operations. The syllabus now begins with this particular point. So here we actually begin what is the classification of the single point cutting tools, of the cutting tools. So here you can say the cutting tools can be single point. So we have already seen, that is shaper, planer, boring. Then multi-point like broach, grinding wheel. Grinding wheel already know, by which we used to sharpen the knives or other cutting equipments. Even at our home, the equipment that we use at our home, we used to sharpen it with the use of particular knives. We have sharpened that particular knives with the use of particular grinding wheels. It is not a common scenario, but you can see few years back there used to be a person who used to have this grinding wheel fitted on its cycle, and he used to come and ask you, he used to visit, means it was a rotary portable unit which you can directly fit on a particular cycle, and he used to travel to the entire places, move, and then the people used to come to them to sharpen their knives, their household equipments which he used to cut, which they used to cut vegetables, fruits and so on. So that is grinding wheel. Broaches, I am going to teach you broaches in details. Broaching is a continuous cutting tool. Now these are the multi-point tools. Now there are certain tools like linear motion tools, lathe, boring, broaching, planing, shaping. Now linear motion means the motion is just in this direction. In milling you are having the circular motion. In broach again you are having this kind of motion. Grinding wheels again it is rotating, but there are certain which are having just a linear motion. So these are called as linear motion tools. So basically the classification of cutting tools is either single point, multi-point, linear motion and rotary motion, and then combination of both. Rotary motion means milling cutter. You can see the milling cutter is rotating, the grinding wheel it is rotating. Linear and rotary. So it is combination of linear and rotary means drills, boring, honing tools. Honing means the tools which are used for producing the gears. We will again see them in detail. So these are the different kinds of classification of cutting tools. Single point cutting tool, multi-point cutting tool, linear motion cutting tool, rotary motion tool, linear and rotary tools. So just we'll see what we have seen. Basically we have seen the different types of manufacturing processes: chip forming, non-chip forming, continuous cutting, intermittent cutting. Continuous means turning, shaping, bowling. These are the examples where you are having just one cutting edge. Then intermittent cutting, that is like drilling, milling. So there is cutting is intermittent. Double edge cutting. Now intermittent cutting is that is milling. In drilling we are having continuous cut. In milling it is coming one by one in contact, so that is an intermittent cutting. Honing and grinding. Then chipless processes like rolling, spinning, forging, stamping. So these are the different processes. Now some important operations like drilling, milling, boring, shaping, sawing, broaching, and we have seen them. What is the classification of tools based on the number of cutting point, that is number of cutting edges, either single point or multi point, based on the motion, that is linear or rotary motion, and combination of both. Now the next important part, that is here the actual syllabus starts. Now we are going to study the two types of cutting, that is oblique cutting and orthogonal cutting. Oblique and orthogonal cutting. So we'll see them in details. What do you mean by oblique cutting and what do you mean by orthogonal cutting? So here you can see this is a workpiece. Now this is the cutting tool and this is the direction of the cutting tool. Here it is shown the direction of the cutting tool, and now the chips are being produced and the chip moves in this direction. Now this is the depth of the cut, that is the material that is been removed, the material that is been removed from the workpiece. So you can easily understand these things. The same is shown here. This is the workpiece, this is the tool, and the chips are being produced like this. This is another view, the view from the front view. You can say this is one view, this is another view. This could be a view from this side, that is you are seeing the workpiece, the tool, and the chip. So what is here? Here you can see this is the workpiece and the tool is fed. It is exactly, the tool is fed perpendicular to it. You can see the direction of the tool. So you can see this is the workpiece and the cutting tool is fed in a perpendicular direction to the workpiece. This is the workpiece, the tool is fed like this. So it is perpendicular to the workpiece. The tool is fed at 90 degrees or it is perpendicular to the workpiece. And the chips, they move in this direction. In this operation the chips are being produced. The same thing is explained here. Here this is the tool. And now this is, if you produce the workpiece, if you provide the motion to the workpiece, the workpiece is moving in this direction or the tool is moving in this direction, and the chips are getting produced like this. This is a very simple operation. The operation which we have seen on lathe machine, we must have seen the single point cutting tool operation in lathe machine. So that is the very simple orthogonal cutting. Here the tool is placed at 90 degrees to the workpiece. Now second one is oblique cutting. So here you can understand this is the cutting edge. This is again your workpiece. This is the workpiece, it is being rotated. The tool is fed in this direction perpendicular, but this cutting edge, it is not exactly perpendicular. It is at certain angles. The cutting edge, it is inclined at certain angles with this direction of feed. So here you can see this cutting edge, it is inclined. It is inclined to what? It is inclined to this particular direction of feed. So there is certain angle which was not there in the orthogonal cutting. In orthogonal cutting, the cutting edge was perpendicular with the direction of feed. The tool was fed perpendicularly. Here the tool was fed perpendicularly, but this cutting edge, here you can see this cutting edge, it is inclined at certain angles to the direction of feed. So that is the basic difference between the orthogonal cutting and the oblique cutting. The basic difference between the orthogonal cutting and oblique cutting is the direction of the feed is exactly perpendicular, that is the cutting edge is directly perpendicular and to the direction of feed, and the cutting edge, it is inclined at certain angles with the direction of feed. So that is the basic difference in orthogonal cutting and oblique cutting. The same thing you can see here. This is your tool. Now here you can see this is not exactly perpendicular. This is not exactly perpendicular. There is certain angle between them. It is having certain angle between them. That is, this is the motion of the work which you can consider. Now this is wherein the feed is being provided. So the direction of feed and the cutting edge, here you can see this is not exactly perpendicular. So you can understand it from this figure. Here you can see it is exactly perpendicular. This tool, I am talking about the tool, not about the chip. This tool, this particular tool, it is exactly perpendicular to this direction of feed, but here the tool is not exactly perpendicular to the direction of feed. Now we will see the difference between them. What is the orthogonal cutting and what is oblique cutting? In orthogonal cutting, the very first difference is the cutting edge of the tool remains normal to the direction of the work feed. The cutting edge of the tool remains normal to the direction of the tool feed or work feed. So that means we have already seen that the cutting edge of tool is always inclined at an acute angle to the direction of tool feed or work feed. That is very first difference which we can already see here. The cutting edge, it remains normal. So this is the cutting edge. It remains exactly perpendicular to the direction of feed. Tool feed or work feed, it is one and the same thing. Either you are feeding the tool, either the workpiece is doing. If workpiece is having the motion, then you can say the work is fed past against the tool. If tool is having the motion, if tool is moved, then you can say the tool is fed past against the workpiece. But we are rotating the workpiece, so we feed the tool past the workpiece. Workpiece is rotating and we feed the tool past the workpiece. So this is very first point. The same thing you can see here. The point is the cutting edge of the tool always remains inclined at an acute angle to the direction of the tool feed or work feed. So here you can see. Is it really there? So yes, here you can see. This particular tool, now this is the cutting edge, so it will be always at certain angles to this direction of feed. You are feeding the tool, so it is always at certain angle to the direction of the feed. The cutting edge is always inclined with acute angle. Acute angle means it will be always lesser than 90 degrees. So this is the very first and the basic difference in the orthogonal cutting and in the oblique cutting. So what is that difference? The very first point is the cutting edge of the tool remains normal to the direction of tool feed or work feed in orthogonal cutting, and the cutting edge of the tool remains inclined at an acute angle to the direction of tool feed or work feed. So this is the very first difference. The second point is the direction of the chip flow velocity is normal to the cutting edge of the tool. The direction of the chip flow velocity is normal to the cutting edge of the tool, and the direction of chip flow velocity is at angle beta with the normal to the cutting edge of the tool. So here you can see the direction of chip flow velocity is normal. So what is the direction of chip flow? So here you can see the chip flow is flowing in this direction. This is the, ये आप देख सकते हैं, here you can see this arrow. This is the direction of chip flow velocity. That means the chips are flowing in this directions. Now the chips are flowing in this. Here you can see, I can read the statement for you. To the cutting edge of the tool. So here you can easily understand this thing. These are the chips. These are the chips, and this is your cutting tool. ये आपका cutting tool है, and these are the chips. They are moving exactly perpendicular to them. This is your cutting tool, so you can understand in this way. This is your cutting tool like this, and the chips are exactly perpendicular to them. So here you can see the chip is moving. This is the edge of the cutting tool, and the chip is moving exactly perpendicular to that particular. The chip flow velocity is exactly perpendicular. So here you can see the chip flow, it is exactly moving, the velocity of the chip flow is exactly perpendicular to the cutting edge of the tool. And in the second, that is oblique cutting, listen here, you have to see the video maybe one or more time to understand the things. Just seeing for the first time, you have to pay your proper attention. You have to draw this diagram of the cutting tool, oblique cutting, orthogonal cutting. You have to show all the things there. today itself in the very first lecture, and to suggest you have to make a special register for this particular subject. Make a register. In that register, draw the important figures, write down the important points, certain keywords. So this will be a kind of notes with you, which will be always helpful at the times of exam. So you have to do that. You have to make a register, special register for this particular subject, and in that you have to mention all the things, all the important points, the diagrams. So to begin with, you have to draw this diagram of the orthogonal cutting and the oblique cutting. You have to draw the position of the workpiece, and you should be able to understand that. And you should be able to understand and show it on the specific diagram. So then and only then your concepts will be completely clear. Here you will just understand the things, but if you do not draw it, if you do not write it, if you do not try to do it by your own, then it will be just in your memory for certain time. After passage of certain point of time, it will be completely erased. So what you have to do, you have to make a register. एक register separately बनाना है tool engineering, and in that you have to mark, you have to draw the important diagrams, you have to write the important points, and if you find it really tedious, you can just write the key points or the very specific ones. Now, the direction of the chief flow velocity, here you can see the next point here, the direction of the chief flow velocity is at an angle beta with the normal to the cutting edge of the tool. So the normal to the cutting edge of the tool, so here you can see, if this is the cutting edge of the tool, now this is the cutting edge of the tool. Now if you draw a normal to it, then to that normal, this particular velocity, it is at certain angles beta. The chief flow velocity is at certain angles beta. Again, just understand this. This is the normal to the cutting tool. This particular line, it is the normal to this cutting edge of the tool. So this line, it is the cutting edge. This particular line, it is your cutting edge of the tool, and this is the normal to the cutting edge of the tool. So the cutting edge of the tool and the normal to the cutting edge of the tool, and this is the chief flow velocity. So it is at certain angles beta. It is at a certain angle beta. So here you can say the chief flow velocity is at a certain angle beta with not the cutting edge, with the normal to the cutting edge of the tool. Try to understand, with the normal to the cutting edge of the tool. So second point here, the next is the angle of inclination I of the cutting edge of the tool with the normal to the velocity Vc is 0. The angle of inclination I of the cutting edge of the tool with the normal to the velocity. So here you can see the normal to the velocity. Now this is the velocity and the normal to the velocity. So normal to the velocity will be like this only. So this is your velocity flow and normal to the velocity like this. So there is no inclination. So tool, it is not inclined. Here you can see the tool, it is not inclined. The angle is 0. The angle of inclination I of the cutting edge of the tool with the normal to the velocity Vc is 0. So here you can see this is only the velocity and this is only the normal. So there is no inclination of the tool. It is at 0 angle. That means it is exactly perpendicular. There is no inclination of the angle. So that is what you can understand. The angle of inclination I of the cutting edge of the tool with normal to velocity, not to the velocity but with the normal to the velocity, that is 0. The cutting edge of the tool is inclined at an angle I with the normal to the direction of work feed or tool feed Vc. So here you can see the cutting edge. So this is the cutting edge and this is the velocity. Now if you draw a normal here, now this cutting edge, it is inclined at a certain angles to this particular thing. Again read that statement for you to understand it better. The cutting edge of the tool is inclined at an angle. Cutting edge is inclined to what? With normal, with not to the work feed but with normal to the direction of work feed or tool feed. With not to the work feed but to the normal to the direction of work feed or tool feed. So this is your work feed or tool feed. Now suppose this is your work feed or tool feed and that is a particular normal to this. So your cutting edge, it is inclined at particular angle. Try to understand in again, suppose this is the work feed or tool feed, this is the normal to it. So cutting edge, it is like this. So here it is your cutting tool, it is like this. So this is your the direction of tool feed or work feed velocity flow and this is the normal to that. So it is inclined at certain angles over here. So this is what it is. The cutting edge of the tool is inclined at an angle I with the normal to the direction of the work feed. Now next, the angle between the direction of chip flow and the normal to the cutting edge of the tool measured in the tool face is 0. Again, the angle between the direction of chip flow and the normal to the cutting edge of the tool. So the direction of the chip flow, so this is the direction of the chip flow, chip are flowing like this, and the normal to the cutting edge of the tool. So you can see this is the normal to the cutting edge of the tool measured in the work face, it is 0. I'll again tell you the angle between the direction of the chip flow and normal to the cutting edge of the tool measured in the plane of the tool face 0. And here 3 mutually, so these 2 points, the cutting edge is longer, this specific point, this particular you will understand in here, but in this point I'll explain you 3 mutually perpendicular components. So when we are going to talk about the effect of the forces, I am going to explain in this point there. There you will easily understand what are the 3 different forces that will be acting at a particular point on a cutting tool. When the tool is cutting is happening, what are the different forces acting? So this point you can understand, but for this thing we will have to wait. I'll teach you in the next lecture. Now the next thing is, what are the principal angles of a single point cutting tool? So this is basically a single point cutting tool. So we will just get its introduction. This is shank. Now this is face. These are the flanks. These are the flank. This is side flank, and this particular thing that is being held in a tool holder. So that is shank. That means the body of the tool. Then it is having a particular, that is face. Then you can say the flank. Flank means this part. This is the flank, side flank. And again there are certain angles in it. So we'll study this tool in detail in the next lecture. So we are going to study this single point cutting tool in the next lecture. Now what you are supposed to do, you are supposed to make a register. You are supposed to go through every video. If you feel, you can rewind it, you can see it twice or thrice for getting your better understanding. And after this you have to attend a Google Meet, and in the Google Meet I'll be sharing you the link of the MCQ. The same used to be pattern. First we'll be having a lecture, a theory lecture, that means a video lecture. You have to go through the video, and after that video lecture I will share a link on a Google Classroom. You have to join us or Google Meet. In that Google Meet I will be sharing the MCQs. So you have to share, you have to submit those MCQs. Attendance is mandatory for each and every lecture. Attendance will be mandatory for each and every lecture. So this is all from today's lecture. I'll see you in the Google Meet. Till then, thank you class. Good day. Take care. Jai Hind.